Hi everybody, Dr. Bingle here. I want to do a quick walkthrough of using some of the cartography tools that are available. So I've just grabbed the cartographic boundary files from the US Census for the states. This is the 1 to 500,000 scale data. And of course, as we bring this in, we get the default projection that's in here, which we can take a look at right here. So this is the projection of the data itself. So if we look at the spatial reference, we can see that this is in NAD 1983, the North American datum of 1983, EPSG code of 4269. This is basically equivalent to what we've seen before as WGS 84. It's a slightly different datum, but the effect is the same, which is an equirectangular projection. So of course, we know that we wouldn't want to visualize the data this way, but this happens to be what the data is recorded in, so we would want to change the map projection. Now we can do that. We can actually see what it is, and we can verify that that's what it was. We could, for instance, stick it back to Web Mercator, which is not so great either. What we're focusing it on today, though, is the cartography tool set. The assignment is really just to work on the lower 48. So let's start with the toolkit. If we go into analysis and choose tools, you'll see all of the toolboxes that are available to you. And one of these is the cartography tools. Now we're going to use something in generalization. There are a lot of tools in here that are great. But what I wanted to kind of just demonstrate here was smooth polygon and simplify polygon. Two very similar tools. One is really going to create sort of aesthetically pleasing smooth shape, and the other one is going to essentially drop vertices to make it a little bit less complicated. Both of these are very similar tools, and part of the assignment is to compare them to each other. For both of these tools to work, though, so let's just start with smooth polygon. We probably are going to want to apply a smoothing tolerance, and because our data is effectively in latitudes and longitudes, the smoothing tolerance is going to be itself in fractions of degrees, which doesn't really make a lot of sense. So the first thing that we want to do actually before we do the smoothing is going to be to project our data. Now, most of the time when we've been doing projections, we've come in here, we choose a coordinate system that we want to work with, and this is projecting the map itself. The Miller cylindrical is a nice little approximation for the lower 48 here, one of my personal favorites. Now, what we've done here is we've changed the projection of the view of the map. But we haven't changed the projection of the data. If we go back in and look at the data is still in the same NAD 83 that it was before. Now, for most purposes, this is fine. Modern GIS is doing an excellent job of sort of smoothing over the rough edges and making things work. But for the simplify and smooth tools in particular, it's going to be more useful if you're working with data that is itself projected. And so what we're going to do here is we're going to project just the lower 48 here. So I'm going to select only these. And this is going to only use the selected records. So it's kind of a handy way to do that. And then I'm going to choose an output coordinate system to make this work. Now, we're going to go ahead and use the Miller, and this is going to be fine. We don't have to shoot for complete accuracy here, but if you may be mapping something where this matters a little bit more than this, and so in those cases you might want to pay attention to things like is the space metrically correct? If this is a small area, maybe you want to be working in state plane or UTM or something like that. But in my case, this is going to work just fine. We're going to go ahead and hit run. And we're essentially going to get a copy of this that's put into our project geodatabase. And now we can uncheck the data that we had before. And we basically get a copy of what we had before, but now it's just the lower 48. And this is going to be convenient for just some of the some of the cartography tools that we want to use here. So let's start out by using smooth polygon. I'm going to grab my projected data set here, and I'm going to apply a smoothing tolerance, probably in kilometers is going to make the most sense here. And so why don't we start out with something that's quite large, and we're going to set it to 100 kilometers. Now, topological errors we'll maybe key in on here as we go. So we've applied this smoothing. We've got smoother results, and we're going to turn off that base layer, and we get to see that. The topological errors, as we zoom in, are going to be these kinds of mistakes that get made. So as we smooth in each individual state, we wind up with sort of holes in our data set. And if we don't want those, then we can try to resolve these topological errors as we go through. This is going to take a little bit more time, a little bit more work, but in the end, we're going to get a version of the states that don't have these holes in them. So topology often matters. And this is a reasonably good approximation. As we crank that number up a little higher, we'll start to see states get quite smooth, quite strange. There we go. So an even smoother layer than what we had. Probably a little bit too smooth to your eye, but pretty interesting nonetheless. Let's go back to 100 kilometers here, and we'll leave it alone after that. So this is the smooth polygon, and what we want to do next is compare this to simplified polygon, a very similar tool. So we'll choose the same input layer, not our smoothed layer. We want something new. This is going to be simplified rather than smooth. We'll set the same 100 kilometers as the simplification limit, and then we will also resolve the topological errors that we see here. All right, now you notice that we get quite a difference. So for most, well, we don't need this layer. We'll go ahead and get rid of that. Now you can already see that we have quite a lot of difference here. We'll change this to something, a different color. So the pink will be our simplified, and the kind of greenish blue will be our smooth. If we want to take a look at these, there's a handy tool, the swipe tool, or even the flicker tool that will go back and forth between these two, which is nice. But swipe lets me control that directly. Turn this off. So on the top is my simplification, which has just dropped to vertices, and you end up with fairly strange results. But somewhere on this line should be vertices that were part of the original. Smooth makes no such promises, but often ends up with a much cleaner result. And both of these have further options that you can go ahead and tune, but you can really quite clearly see the difference between the two. Even as we zoom in, the one is going to make a lot more sense than the other. All right, so the job for the notebook is really just to kind of comment, run both of those tools to comment on the differences. That includes projecting the data. Hopefully this was instructive for you, and we'll catch you next time.